In this video, we'll explore a Shiny app that is going to show you the sampling distribution of a sample mean. So on the left side of the window here, we have a whole bunch of controls that we'll use to change the distribution, which is going to be graphed over here on the right side. So the website is up here in the address bar. The first thing you'll want to do is select some data. So I'm going to choose real population data, but you can also choose data that is just a generic skewed distribution or uniform distribution, depending on our goals of the activity. So I'll choose real population data, and I'm going to look at the age of soccer players. It's one of the preloaded data sets, but you can also explore some other data sets: college costs, distance of NYC taxi rides, delay of flights leaving Atlanta, Georgia. Kind of curious about that one. Oh, very skewed. Okay, so back to age of soccer players. So when you choose your data set, it's going to show you over here in this box a little snippet of the data set. It'll also tell you above the box what the variable is. So age of all soccer players listed in FIFA 19, which is an online soccer game, if you will. And it gives you the population, and then there's the website where the data was collected from. So to the right, we have the population distribution. So this is of all 18,159 cases reported in this data set. Here's the average age for the soccer players, and there's a standard deviation of the age. And then you can get the shape of the distribution there. So what we're going to be doing is taking samples from this population and then looking at how the samples vary. So we can choose the sample size on this slider. It started at a default, but you can choose a larger or smaller sample. I'm going to go back to size 12. You can also check the box and then enter a number if you want to not use a slider. Say you want to use 53 for the number in your sample. This box down here in the orange, it'll tell you how many samples of size 53 that you want to simulate, and then with the blue button you'll push draw samples. So let's say I click on one. I just want to take one sample of 53 soccer players. I click on the blue draw samples button, and then two more graphs show up. Population didn't change, which we expect. But then this middle graph here is a data distribution. So from that one sample, it is showing me the ages of those 53 people. And then like the population distribution, there is the red semicircle to show you the mean of that sample and of the population. So it's comparing the two. And then up at the top, it'll give you the sample size, the sample mean, and then the sample standard deviation. So again, all going back to that one group of 53 people. And below the box where we chose how many samples to take, it gives you the values from the last sample generated. So if we take lots of samples, it's only going to be the last sample. So here's our data set. You could easily copy those out and then put it into a spreadsheet if you wanted to. So the third graph is telling us, okay, here is a summary with just statistics from that one sample. The mean was 25.4, so there's a blue little triangle there. And then it tells us, reminds us that we did one simulation of a sample of 53 people, and then that one sample mean was graphed. Okay, so the idea of a sampling distribution is that hypothetically, if we could take lots and lots and lots of samples of size 53, what would that graph end up looking like? So I can go back to my blue button that says draw samples, and I could click on it one more time, and I'm going to get a new group of 53 people. Actually, there may be some repeats from last time, but it is 53 randomly selected numbers again. Here's my distribution. So I see the application chose, let's see, between 17 and 18 years old, there were 2 people selected. And maybe this is like 19 to 21. It looks like there were 8 people selected. And there was one person selected who might have been 38 or 39 years old. Oh, actually, I can go back to the last sample. I can double check that and see how many people of each age group exactly were selected. And it looks like there was one person who was 40 years old that was selected. And then we go to the third graph and that second sample mean. So this time the average is 25.6. I can read it from the middle graph. And it's being graphed here on the third graph down below. I can also tell that the subtitle is 2 simulations of samples of size 53. So there's 2 little blue triangles here on this third graph. Let's keep drawing samples. Every time I collect a new sample, I get 53 new people. I get 1 more sample mean. So in the third graph, I have now a third sample mean. And the idea is to look at how these sample means are shaping up. Where are they stacking up? So I could keep clicking here on draw samples. So what you notice is each sample will vary. Each sample from the population will vary. But then down in the third graph, we're sort of starting to see a pattern as these little blue bars start to stack up. So it was hard to see when we only had a couple samples, but now it's more clear that there are definitely some more sample means that are like more popular, if you will, than other sample means. And they're kind of creating some modes. Looks like there's some gaps there, which is kind of interesting. And you'll begin to see a pattern of what you would expect to be an expected or a kind of normal, if you will, average, average age for the soccer players, and an average that would be kind of unusual. So down here, an average that might be in the 23 range doesn't seem to be very popular, but maybe in the mid 24s or maybe high 25s, that seems to be a pretty expected average. So I could speed this up a whole lot. If I click 100, I could take 100 samples instead. And maybe we hit the limit here on this distribution, or maybe 1,000. Well, let's just reset. Let's see what happens. Oh, I know what I did. I did not click draw samples. There we go. So now here is 100 samples that have been collected. So 100 groups of 53. Each group of 53 had its mean computed, and then that mean was graphed down here on that third histogram. If I want to collect 100 more samples, it's just a click of a button. And now you can see what's happening with all of those little sample means. And the important part is to watch what happens to the blue triangle against the red, because the red is the population mean, and you're wondering, well, how does the average of all of these sample means stack up against the population? And you should expect that they should look about the same. Now, when you take one single sample, the sample mean might look really different than the population mean, because that's just one little sample. You might just happen to get all the weird odd numbers, really large or really small, in your sample. But when we start to look at averages, those extremes sort of fade away because there's more normal numbers than there are abnormal numbers, if you will. So we'll tend to see numbers cluster towards that center of the population. And if we want to go really crazy, we could take 10,000 samples, take a few more of those, and you'll see what happens. And you end up getting a pretty nice bell shape with enough samples, even if your population didn't start off very normal. So another couple of options that you can use here in this applet is you can check the box to show the normal approximation to see how close your sample data matches an actual normal approximation. You can change the x-axis if you want, and that might make things a little bit nicer to read. As you change variables, your axis won't change, so this can be handy to do. I probably should have done it in the first place. You can click on Summary Statistics of the Sampling Distribution. So that's the third graph here, the sampling distribution. Here's the mean, the standard deviation of all those samples, and then the min, the 5-number summary, and the IQR. So what's kind of fun is if we reset this, let's say we take a different sample size, let's say 5, and it looks like 10,000 samples were generated. You can look at the standard deviation here of this sampling distribution. What happens when you have different sample sizes? You want to be able to look at what happens with the IQR. How do the quartiles change? How does the mean change? Here's another group of 10,000. There we go. So another couple things that we can do is when we start comparing distributions, especially as we change sample size, we can find percentiles for a sampling distribution. So if I look at this box, which percentile in terms of percent, by default it's giving you the 97.5th percentile, and it should be giving you, let's change our axis. Find probability, check that box. Let's see, which percentile? Oh, here we go. What was shown, it just showed up down here in the bottom. The 97.5th percentile is at the value 29.4. So go to the axis here, look up 29.4, and that little cutoff there, that tells you that 97.5% of the data are to the left and 2.5% are up to the right. So maybe I want to change this to 95. And now down here in the box, the 95th percentile is at the average of 28.8. Now you can do an opposite question, find probability. Find probability at or below which value. So maybe I want to look at an age of 22. What percent of all of the averages are below 22? So we had 22 was the average, that's the cutoff that I just arbitrarily made. We had 20,000 simulations, and the number of simulations resulting in sample mean less than or equal to 22. There was about 1,370. And then the proportion of that, so do the math, so it was about almost 7%. So if we look here at the 22, about 7% of our data fell at 22 or below. So less than or equal to 22. And then if you wanted to look on the higher side, let's say we want to look at an average of 30. So how many of my, or what percent of my samples had an average that was 30 or more, or maybe more than 30? Here we have 30 is our cutoff, number of samples that had a mean less than or equal to 30, so almost 20,000. So here we have almost 99% of samples had an average that was 30 or less. So then you can work backwards and figure out how many samples and then what proportion had an average age of more than 30. And then you can also download the graphs if you like to do that. So you can choose which one you want to download. All right, so that was on an exploration of a sampling distribution. And when we're actually using a sampling distribution, we're not generating all of these samples, but all of this is background information so that you know what to do when you're faced with a problem that talks about a sampling distribution. You can have this picture here in your head, and then you're asking, oh, okay, I'm finding the probability that I land in this region of the sampling distribution.